Welcome to Study Loop.
All right, this is question 8. We are given y double prime minus y equals x times e to the 2x. This is going to be r squared minus 1 equals 0. Then, of course, I would factor that to r plus 1, r minus 1, which equals 0. Therefore, r equals plus or minus 1. Setting up the start of my complementary equation. So far, I have c1 e to the x from my 1x for r plus c2 e to the negative 1x. Next, I'm going to set up to find my a and b. So I have y equals ax e to the 2x plus be. Y prime then, of course, would equal, I have to do the product rule for ax e to the 2x. So I do f prime a e to the 2x f prime g plus g prime. So g prime would be 2e to the 2x. So I have 2a times x e to the 2x plus, b e to the 2x. Y double prime, the derivative of a e to the 2x is just product rule. No, not product rule, just 2a. The derivative of the e to the 2x, that would be my chain rule. So I bring down the 2, a e to the 2x. Now here I have to do the product rule because I have x times e to the 2x. So my f prime, I have 2a e to the 2x plus g prime would be 4a x e to the 2x and then plus b e to the 2x. So for y double prime, I'm going to combine like terms. So this term and this term give me 4a e to the 2x plus 4a x e to the 2x plus b e to the 2x. All right, now I'm going to put that into my y double prime minus y equals x e to the 2x. So my y double prime is 4a e to the 2x plus 4x, no, 4a ax e to the 2x plus 4b e to the 2x minus, and I'm minusing the quantity, so I'm going to minus both components, ax e to the 2x minus b e to the 2x equals x e to the 2x. So let's see, I can combine this one and this one, and I can combine this one with this one. So I get 4a e to the 2x plus 3a x e to the 2x plus 3b e to the 2x equals x e to the 2x. So now I'm going to get my x's, and the only x's I have is 3a x e to the 2x equals x e to the 2x. Keeping x e to the 2x the same means that 3a has to equal 1. A would equal 1/3. Now I'm going to my non-x's. So I did that. So now I'm going to have 4a e to the 2x plus 3b e to the 2x equals 0. So 4a plus 3b equals 0. A equals 1/3, so this is 4/3. Plus 3b equals 0, or 3b equals negative 4/3. Multiply both sides by 1/3 gives me b equals negative 4/9. So now my general equation so far is y x equals c1 e to the x plus c2 e to the negative x plus 1/3 x e to the 2x minus 4/9 e to the 2x, and I have to solve for c1 and c2, so I put in my initial condition of 0, 0. So 0 equals, everywhere I see an x, I'm going to put in a 0. So e to the x is 1, so I have c1 plus e to the negative 0 is 1, so I have c2. That wipes out the 1/3 term, and then I have e to the 0 power gives me 1, so I have minus 4/9. Now I have to take the derivative of that, so I can put in my second known condition. So the derivative of that function, y prime of x equals c1 e to the x plus c2 Nope, that would be minus C2 e to the negative x. And I have to do my product rule here, so I get plus 1/3 e to the 2x would be my f prime times g, plus 2/3 x e to the 2x, which is my g prime times f, minus 8/9 e to the 2x. All right, so now every time I see an x, I'm going to plug in a 0, but this is going to equal 1 instead. So I have C1 minus C2 plus 1/3. X is going to wipe that out. Minus 8/9. So this becomes 1 equals C1 minus C2 minus 5/9. So I set these two equations up as 0. Let me set them up. I have 4/9 equals C1 plus C2, and then I have 1 5/9, which is 14/9 equals C1 minus C2. I see the C2s will drop out, so I'm just going to add down, and I get 2C1 equals 4/9 plus 14/9 is 18/9, which is 2. So C1 equals 1. Replacing that back into my equation, I get C2 to equal negative 5/9. So now I'm going to take my red equation and plug in negative 5/9 for C2 and 1 for C1. So plus, I have my final equation equals 1 e to the x, so I'm just going to write e to the x, minus 5/9 e to the negative x, plus 1/3 x e to the 2x, minus 4/9 e to the 2x. Voila, done.